Hi, I'm Jason Specklin, the Cloud Solution Architect at Microsoft, and this is today's Azure Dev Tip. In today's tip, we're going to talk about how your JavaScript single-page applications can authenticate to Azure Active Directory. Now, Microsoft has just released version 2.0 of MSAL, that's the Microsoft Authentication Library for JavaScript. Now, version 1 of MSAL supported OAuth 2.0 Implicit Grant Flow, whereas version 2.0 doesn't support that. It supports the OAuth 2.0 Auth Code Flow with PKCE. What's the difference? Security. But before we get into how to update your applications, and don't worry, it's actually pretty easy, let's dig a little deeper into how these OAuth flows actually work. I bet you're thinking, I'm about to show you a diagram that looks like this. But I'm not. You see, these diagrams are great and all, but sometimes I feel an analogy can be a little more instructive. So this is my analogy. Bear with me for a moment, okay? So in this analogy, we have a jewelry store. And this jewelry store keeps all of its best jewels inside a safe deposit box here at the Bank of OAuth. Now, they would like for their employee to be able to go into the safe deposit box and get a blue diamond for their customers. Now, what they could do is just give their username and password to their employee, and their employee would go to the safe deposit box, and they could get the blue diamond, and the red ruby, and every other jewel in the place, and run off to a country that has no extradition treaty. That's not what we want to happen. But if you think about it, that's actually the way we kind of treated applications for a long time. We just gave our username and password up and hoped for the best. But thankfully, OAuth came around to kind of relieve us of this burden. So let us imagine another way that this might work. So here, the employee has an ID separate and distinct from the ID and password of the jewelry store. So in this case, the employee goes to the first teller, presents his ID, and says, "I am Jason, and I would like to get the blue diamond." The teller then calls the jewelry store provides their username and password, and the teller says, "Hey, Jason is here and wants to get the blue diamond. Is that okay?" So the jewelry store will say yes, and the teller will print out a ticket. And this ticket says, "Jason from the jewelry store can get blue diamonds for 1 hour." The teller will give me the ticket, and I will take it to the security guard. Now, the security guard is always a bit suspicious. So the security guard's going to call teller number 1 and say, "Hey, did you print this ticket?" The teller will say, "Yes, I did." So the security guard will let the employee into the safe deposit box and allow the employee to only take the blue diamond. So how does this actually work in the real world? What is this analogy all about? So in this case, the jewelry store represents the user, and this employee represents the app, which might not be entirely trusted. So the app then connects to the authentication endpoint. The authentication endpoint redirects the user, okay, this is kind of where it breaks down a little, redirects the user to the login screen, asks them to log in if they're not already logged in, and then presents them with the permissions that the app is requesting, or the scope. So in this analogy, the scope the app is requesting is the ability to get blue diamonds. In the real world, the scope would be something like can read your email or can write to files. So it will pop up that permission request separately and distinctly from the authentication. If the user approves of the scope, then the authentication endpoint will produce an access token. That access token will be returned to the app the same way the app got there, by redirecting back to that application. Now, the way the redirect works, this token actually needs to appear in the URL fragment of this URL. So it's going to be redirecting back to the URL of the app with the access token stuck on after like the hashtag. And then the app can grab that access token and will present it to the API as a bearer token. The API then should check the validity of that access token and then allow the application to do what is requested in the scope. So in our analogy, getting blue diamonds; in the real world, reading emails, writing files, etc. However, there is a problem. Let us imagine instead that a hacker has taken up residence inside of our bank. So what happens is the employee goes to the teller, says, "I am Jason. I would like to access the blue diamond." The teller then calls the jewelry store. The jewelry store provides their username and password. The teller asks, "Hey, can Jason get blue diamonds?" The jewelry store says yes. The teller prints up a ticket that says Jason from the jewelry store can get blue diamonds for 1 hour, gives it to Jason. But at this point, the hacker takes a picture of the ticket. The hacker then goes to the security guard, shows them the ticket. The security guard validates the ticket, and it is valid. The teller did print it out, and so allows the hacker to get in and steal blue diamonds from the safe deposit box. So what's the actual real-world flaw here? Well, it comes from this token. Again, remember, the user agent was redirected to the auth endpoint, and the auth endpoint needs to redirect right back. So this access token is going to appear right in the URL bar. So in this analogy, this hacker has to do a fair bit of work in order to get this to happen. He has to set up in the bank, he has to have a camera, he has to not be noticed. In the real world, the way this kind of hack works is there'd be some cross-site scripting vulnerability, so a JavaScript injection, or a rogue NPM package, or perhaps even just some plain old malware running somewhere else on this user's computer. So it takes some doing, but it is very possible for this hacker to be able to steal that ticket. So what can we do about this? How can we mitigate this and prevent the hacker from stealing the blue diamonds? Well, let us imagine in this other case that the employee now not only has a username, but also has a password. So in this instance, the employee goes to the teller and says, "I am Jason, I would like the blue diamond," does not provide a password. The teller then calls the jewelry store. The jewelry store authenticates with their username and password. The teller says, "Jason would like to get the blue diamond." The jewelry store says yes, and so the teller prints a ticket. Now this ticket is different. This ticket says Jason from the jewelry store can get one token, in the next 10 minutes. He then gives him that ticket. He takes that to the next teller, but he puts them in an envelope, hands the envelope to the second teller. The teller then verifies the password, and then the second teller prints out a ticket that says, "Jason from the jewelry store can get blue diamonds for 1 hour." He then puts that ticket inside an envelope, and now Jason can get that ticket, use it to present to the security guard. The security guard will always check with the teller to make sure he printed it, and then will allow Jason into the safe deposit box to get the blue diamond. How is the hacker thwarted? The hacker is thwarted because by putting it in an envelope, the hacker can't take a picture of it. And because this response is inside an envelope, that hacker can't take a picture of that either. So, again, how does this very stretched thin analogy actually work in the real world? Well, the way it works in the real world is that from the first teller, you're getting an auth token. And this auth token allows you to get one token in the next 10 minutes. So again, this redirect does have to happen in the URL fragment. So the hacker can still take a picture of that. Okay, that ticket is still open and available for a well-situated hacker to get at. But what the hacker does not have is the password. So the hacker can certainly get his own envelope and can certainly hand it to teller number 2, which is the token endpoint. But that hacker doesn't have the password and so will not get this ticket that allows the app to authenticate to the API using it as a bearer token. He puts that in an envelope, which is to say the response to the post request that was sent earlier. Again, something a hacker is not going to be able to see easily. And then he uses that to authenticate to the API, doing the things that the scope allows him to do. And this works great, except for one problem. The problem is, this guy cannot keep a secret to save his darn life. See, this guy is a JavaScript single-page application running in the context of a browser. Now, this flow works great for confidential clients. It's called the OAuth 2.0 Auth Code Flow. But there is no place that this guy can store a secret where this guy can't already just reach in and grab it. He could store it in local storage or a cookie or something, but this hacker is always going to be able to get that password, rendering this whole thing moot, which is why the implicit grant flow exists at all. How can we get around this issue and still be secure? Well, what we can do is use the newer OAuth 2.0 Auth Code Flow with PKCE. That's Proof Key for Code Exchange. So in this instance, we have the employee once again who has an ID but no password. So the employee once again goes to the first teller, says, "I am Jason and I would like the blue diamond." The teller then says, "Okay, think of a number between 1 and 100. So the employee thinks, okay, 38, why not? And then the teller then calls the jewelry store. The jewelry store authenticates with the username and password. The teller asks, can Jason get the blue diamond? The jewelry store says yes. And so the teller prints up a ticket that says Jason from the jewelry store can get 1 token in the next 10 minutes, just as before. So then the employee takes the ticket as well as the ID and the random number that he just thought up and puts it in an envelope, and then within the next 10 minutes goes to the second teller. The second teller then verifies that the random number that is in the envelope is the same one that he thought of less than 10 minutes ago. If that is the case, he will print up a ticket that says Jason from the jewelry store can get blue diamonds for 1 hour, put it in an envelope, then the employee can get it from the envelope, go to the security guard, present it to him. The security guard, as always, will check the ticket, make sure it was printed by teller number 2, allow the employee to go into the safe deposit box and get the blue diamond. So, in this case, the hacker is thwarted by the random number, okay? So the hacker can't see the random number that the employee thought of. The hacker can't see this number 38 over here. As before, the hacker can absolutely see this Jason from the jewelry store can get 1 token in the next 10 minutes ticket, and he's got to operate fast if he's going to get it first. But what he doesn't know is that random number that the employee thought up. So there's no password to be discovered, and the hacker is thwarted. So how does this work in the real world? Well, in the real world, instead of thinking of a number between 1 and 100, the client needs to create a cryptographically random string and present it to that authentication endpoint. Then the authentication endpoint will provide it with the token. The auth token, again, because of the way the redirects work, must be on that fragment of the URL. So again, trivially gettable by that hacker. But what the hacker does not have is that cryptographically random code that was presented to the first teller. So then the second teller or the token endpoint, will verify that this post request contains that very same cryptographically random string. And if it does not, he will not issue the bearer token that allows the app to get into the API. So, with that very stretched thin, very elaborate analogy out of the way, let's see how you can actually modify your MSAL code to take advantage of this new OAuth flow. So here I have a simple single-page JavaScript application written in Vue.js. Now this application can authenticate using both MSAL 1 or MSAL 2 as the user chooses. So here is my MSAL 1 service. And to do that, I import star as MSAL from MSAL. That's the name of the NPM package. And to create my MSAL object, I do this.myMSAL equals new MSAL.userAgentApplication, and I pass it in my configuration. Now let's take a look at the MSAL 2 auth service. Here I import star as MSAL from @Azure /MSAL browser. That's the new name of the MSAL 2.0 package. So if you start upgrading just MSAL, you're not going to get 2.0 because they work pretty differently. So then we create it by saying this.myMSAL equals new MSAL.public client application, and we pass it in the config. And that's essentially it. I mean, it takes the exact same configuration as MSAL 1. It just uses an entirely different flow behind the scenes. Other than that, everything just works the same. It's pretty easy to upgrade. So let's see this application at work. All this app does is it authenticates using the library of my choice, and then it just goes into Office Graph and gets all the groups that I'm a member of. So first, let me select MSAL1. I will log in, and I'll give it my username and password. And then I will select Get Groups, and that is going to actually request the auth token. So I'll click on that. And you can see that it got the groups that I'm a member of, so it worked. That's always nice. And we can see here that here's the URL that I got. And remember, these have to be GET requests because it works all through redirects. Here I have the redirect URI that's encoded in there, and all this stuff is encoded right there in that URL. And you can see what it's going to call me back with. It's going to call back this localhost address, and here, right on that URL bar in the fragment, is my access token. Okay, I can take this access token as is and present it to the Microsoft Graph, and for as long as this token is valid, which should be about an hour, it will allow me to get all the groups. And so here's me making that call. I'm using a GET request, and I am providing it with that bearer token. And that is the implicit grant flow at work. Now, let's see the exact same thing, but this time using MSAL 2. So I'll click MSAL 2. I will log in. It's going to, once again, pop up an authentication window. My username and password will be entered. Okay, and let me get my groups. And there are my groups. So here, let's take a look at the token endpoint that we called. Oh, so this is the options call we got to verify we could do cores. And here is the post request we made. And if we look into this post request, we can see first the auth code that we got from our initial call when we logged in, as well as the code verifier. And that is that cryptographically random string that we need to generate and then present to the token endpoint in order to get a bearer token. And here you can see we called the member of endpoint, and we had a bearer token to call. And that shows just how easy it is to make your JavaScript single-page applications just a little more secure by using MSAL 2.0. This has been today's Azure Dev Tip. Thank you so much, and as always, happy coding.